Okay guys, today we are doing a STAAR review with similar figures. So you need your flipping out with similar figures worksheet, and you need a pen or pencil, and if you have a highlighter around, that would be great. So this is just a real quick review. It says similar figures have the same shape, but they have different sizes. Similar figures have the same shape and different sizes. If you remember, the angles are congruent, which means they are the same. So the two figures have the same angle measurements. When we do similar figures, they can be rotated, they can be flipped, and the last one is within each other. So sometimes you'll have a triangle within a triangle like that. So there's a figure within a figure. Alright, and then we also talked about dilating a figure here. So when you dilate a figure, this is when something is enlarged. So a dilated figure will enlarge or reduce the shape. So it can get bigger or smaller. And then with dilations, we had a scale factor. And if your scale factor is greater than 1, what's going to happen is you're going to multiply, and you're going to end up with a figure that is enlarged. So it's a bigger figure. Then, if you have a scale factor that is less than 1, your figure is reduced. Okay, so we're going to use that information there to go through the 5 questions that follow. Number 1, the graph below shows triangle XYZ and similar triangle X prime, Y prime, and Z prime. Which statement is true? So before I even look at my answer choices, I know that I'm going from triangle XYZ to triangle X prime, Y prime, Z prime. So I'm going to draw from here to here. So be careful, because this is your prime here. So you're going from a little figure to a big figure. So write yourself a note. And I know from up here, if I'm going to enlarge something, from going small to big, my scale factor has to be greater than 1. So that tells me, okay, a scale factor of 3, so I think that's okay so far. A scale factor of 1/3, that's not good. That's going to make it smaller, so B's out. C says a scale factor of 3, and D says a scale factor of 1/3. So I've gotten rid of 2 choices just by knowing this. When I go and look at the answer choices a little better, A says all corresponding angles will increase by a scale factor of 3, and C says all corresponding sides. So if you look up at the front, it says all the angles are congruent, which means the angles are not going to change. So that means A is out, and choice C is our answer. So you really didn't have to do a lot on that problem if you remember a little bit of your vocabulary there. Number 2, we need to make one little change. If you will cross out this 1/2 right here, so just make it a 2. It says your teacher puts a worksheet with a rectangle like the one below underneath the document camera. If the projector dilates the figure by a scale by a scale factor of 2, what is the area of the new rectangle? So I'm going to try to draw myself a little thought bubble here. I'm dilating the figure by a scale factor of 2, and then they want to know the area. So first I need to dilate, and then I need to find the area. So I can't forget to do both steps. So I'm going to do this problem using a table. So if you will draw yourself a 3-column table, and in the first column we write original, in the second column is always our process, and the third column you'll write new. So we're going to start with the original amount, so 2 1/10, and then 0.3. I need to dilate both of these by a scale factor of 2, not just one. But I really don't want to deal with that fraction there, so I'm going to make this 2.1. So the process for a scale factor is multiplying by 2. So I'm going to write 2.1 times 2, and I'm going to write 0.3 times 2. So remember both sides. So on the side I'm going to do 2.1 times 2. So 2 times 1 is 2. 2 times 2 is 4. And I have 1 decimal place. So this new length here is 4.2. But now I need to find the other one. So I'm going to do 0.3 times 2. 2 times 3 is 6. I have 1. So now it is 0.6. So I did step 1, which is my dilation here. Now I need to go and do the area. So, in order to find the area of a rectangle, area is length times width, or you could have area is base times height. It means the same. So I'm just going to do 4.2 times 0.6. Watch your decimals when you multiply at the end. 6 times 2 is 12. 6 times 4 is 24 plus 1 is 25. I have 1, 2 behind the decimal, so I need 1, 2 here. So the area is 2.52 inches squared. But I'm not done because this is a griddable, and you're going to have, I think, 4 of these on your test. So it's 2.52. So you need to write that in, and you need to bubble the 2, the 5, and the 2. Now, you do have empty spaces there. If you want, you can put in zeros. You do not have to. And you can bubble those, or you can leave them blank. It's totally up to you. But these here, the 2, 5, and 2 with that decimal in the middle, those are the ones you have to have. Alright, we are going to go to the back side of your paper. Number 3, Stanley found 2 empty cans in his garage. He wants to find the height of the larger can but does not have a ruler. If the 2 cans are similar, what is the approximate height? So, I know that they're similar, which means I can compare them. I am looking for the height of this, and it says right here, X inches. So, I'm going to set up a proportion. And I'm going to think about what I'm comparing. I know I'm comparing a small can to a large can. So I'm going to write small and large. So my 2 fractions will be comparing small and large. But I also have another comparison here I need to think about. So I'm going to say, okay, well I know its height is one of them because that's what they're asking for. But when I go look at the other, this gives me a diameter and this gives me a radius. So I can't use them that way. I have to use one or the other. So because this one's a decimal, I don't want to mess with it. So I'm going to go with diameter. I can make that other one into a diameter as well. So when I look at the small can, the height of the small can, and remember, a height is from base, so this is a circle, to base. So from here to here, that is a height of 5. The diameter all the way across is 4.2. Then I go to the large can. I don't know the height. That's my X. And I'm looking for the diameter. If the radius is 3, that's this half. That means this half is also 3. So all the way across would give me 6. So that's how we set up our proportion. There's different ways. Now I need to cross multiply and divide. So I'm going to do 5 times 6 equals 4.2 times X. I know that 5 times 6 is 30. 4.2 times X is just 4.2X. But now I see multiplication, so the inverse of that would be division. I want to get the X by itself. I don't know what 30 divided by 4.2 is, so I'm going to divide. And when I look at this, it says approximate, which tells me I'm not going to get an exact answer. So I'm going to go ahead and divide by 4.2 because my answers are close, but I need to hop the decimal. 42 goes into 307 times, and 7 times 42 is 294. So when I subtract, I know that's 6. So if I look at my answer choices, right now it looks like B is my answer, but I do want to go a little bit further because I have this not here. Please don't go and choose not here just because it's there. So 42 goes into 61 times. And then I'm going to do it one more time just to make sure. 42 times 4 would be 168. So I would do minus 168. So it is 7.14. Now you will have some problems on STAAR where it says not here. It is possible that that's the answer, but don't just go and choose that because you see it. Number 4. If LM is 9 inches, MN is 3 inches, and ON is 4 inches, what must be the length of PM? So I'm going to label what I know. LM is 9, MN is 3, ON is 4. So right now I see a little triangle inside of a big triangle. So in order to help me out, I'm going to draw 2 separate triangles because that's a lot for me to look at. So if I look at the small triangle, which is right here, I know it has a base of 9 and a height I don't know. That's PM, so I don't know that. But when I look at my big triangle, I know the height is 4. But the base of my big triangle is all the way across. It's 9 plus 3, which is 12. So I'm comparing two things, so I need a proportion. I know I have a small triangle and a big triangle, and I'm comparing base to height. So the base of my small triangle is 9. The height of my small triangle I don't know, so that's x. The base of my big triangle we added to get 12, and the height of that is 4. Now I don't have to cross multiply and divide here because I know 12 divided by 3 is 4, so this has to be the same relationship. So 9 divided by 3 gives me b, which is 3 inches. Alright, last problem. A tree stands 20 feet tall and casts a shadow. A fence stands 4 feet tall and casts a 7-foot shadow. How far is the tree from the fence? So here's our tree, and here's its shadow all the way up to here. Here's our fence in the shadow. We want to know here. How far is it from here to here? In order to do that, I've got to find the whole shadow of the tree. So I'm comparing the fence to the tree, and I'm comparing height and shadow. So when I look at the fence, what is the height of the fence? It's 4. The shadow of the fence would be 7. The height of the tree is 20, and I don't know the shadow. I know part of it, but I don't know all of it, so I'm going to put an X. And so I got to cross multiply, divide. So 7 times 20 equals 4 times X. Well, I know 7 times 20 is 140. 4 times X is just 4X. So I've got to use inverse operations and divide by 4. So X is 35. So when I go and look at that, that means this whole thing, this whole shadow of the tree is 35. But the question says, how far is the tree from the fence? I only want this part here. If this is 7, I can take that 7 from the 35 and get 28. So I know this smaller, or this piece here is 28. If you go and check it, 7 plus 28 adds up to 35. So in your grid, you need to put a 28. And remember, this is 28 point, and then you have zeros behind it if you want. So you have to bubble the 2 and the 8 here and here. Other than that, if you want to put in zeros afterwards or before, I know a lot of you like to put them after, you can, but again, you do not have to. Alright, that is the end of your video. Thank you.